Hey everyone, welcome to my session called Crash Course in Transpiling and Ruby. This is RubyConf Belarus 2020 online edition. So let's go. So we're going to talk about Ruby, more precisely about the latest Ruby or even upcoming Ruby features, Ruby 3.0, which is currently called 2.9. 8, sorry, but that's just a working title. I hope it will change to 3.0 somewhere in December. What is Ruby 2.8? So let's take a look at some new features. For example, pattern matching. It's been a while since pattern matching has been added. You might be already using it, but it's going to be more performant, more functional in 2.8. Also, there is a new thing called endless method definition and also write-word assignment. So this is just a few new things that will come to Ruby at the end of this year. And they're going to be much more, I think. So Ruby is evolving faster than ever nowadays. And it's kind of hard to keep pace with this evolution for different reasons. So we still have to maintain our application running on older versions, and most of us not using even 2.7 because it takes some time to upgrade and it's not free. Gem offers have to support older versions for the same reason. You cannot just ship a gem with the latest features because no one's going to use it. So we need something to help us to use these new features today without waiting for everyone to upgrade for all different Rubies. We're not only talking about MRI, but JRuby, Truffle Ruby, MRuby, Opal, Artichoke, and so on and so forth. So there are a lot of Rubies nowadays. All of them will have to, to add this feature someday, but not right now. So we need something that will help us to use these features right now, today, even before their official release. And there is one thing that's called Transpiler, which could be handy here. So you might probably heard about Transpilers from the JavaScript world. So the most popular transpiler out there nowadays is Babel. It's a JavaScript compiler, which is just a transpiler is a specific kind of compiler actually, but we're going to use transpiler naming. Another one for CSS is PostCSS. It also acts as transpiler. That's one of its responsibilities. And from the very recently, we also have a transpiler for Ruby called RubyNext, which is I'm the author of. So I'm going to talk about how RubyNext works today as a transpiler. So what Transpiler does for Ruby. Let's take a look at a quick example. So assume we have a Ruby 2.5 and we want to run this code. So this code obviously should raise an exception because Ruby 2.5 doesn't know about pattern matching. But with this little switch, RubyNext, we can make it work. So that's what transpilers could do. And that's what we're going to talk about today, how to make this work. So a few words about me. My name is Vladimir. I'm currently living in Moscow and work for the company called Evil Martians. We're a distributed team across the globe with 4 bases in different countries. And you probably heard about our open source projects, of course, and maybe read some of our great articles in our blog. So we are a consultancy agency. We're helping others to build great products, to build performant products, and that's what we're doing. That's what we're writing about in our blog. That's what our open source aims to help with. But today we're going to talk about transpiling Ruby. Let's switch to the main topic. So what is transpiling? As I said, transpiler is a special kind of compiler which in its turn is something that transforms, say, program code from one representation to another. Usually we talk about compilers when talking about the final machine code or packed into some binary container. But Transpiler is a compiler which has equal or very similar input and output. In other words, we're taking Ruby, say, to 8 source code as an input, pass it through the transpiler, and as an output, we have a Ruby, say, 2.5 or 2.6 or whatever source code, which could be run on this version. So we compiling Ruby to Ruby. So how can we do this? We can do this by hand. So just like, let's rewrite pattern matching into a bunch of ifs and else. That's how it could look like. Or another naive approach is just, okay, we can just replace new syntax with something working on the older versions, and we can just use, I don't know, regex for that, like this. And that could work at some, level for some of the features like method reference. Yes, I'm going to talk about method reference today because it's a very simple one, even though it has been reverted from Ruby, but we're going to use it as an example. Also, args forwarding could be implemented somehow as this regex version of Transpiler, but you might realize that you can't go far with this approach, because for most features you need to know about the context of this particular string. So you can't deal with strings to transpile code. Really, it's almost impossible, only for such simple cases. In other situations like pattern matching, for example, or numbered parameters, you can come up with a regex to fix this. You need something more powerful to analyze the source code. And a typical way of transpiling, independently of language or platform we're in, is following. We get a source code, we transform it, we parse it into an abstract syntax tree. Then we do something with this abstract syntax tree. For example, we can replace nodes with older style nodes, like just rewrite case in with if and else, right? So we can build new nodes. And at the last step, we generate a new source code for this modified abstract syntax tree. So that's how transpilers usually work. Let's talk about all the phases. So first phase, we need to transform source code to the abstract syntax tree. We have a bunch of tools to do that in the Ruby world, starting from Reaper, which is building library which goes with Ruby, which allows you to transform source code into not actually abstract syntax tree in strictly speaking, but a series of S expressions. But that's out of this talk. Let's skip it. We're not going to use Reaper. Also, from Ruby 2.6, we have a RubyVM abstract syntax tree module which produces syntax trees. And finally, we have a major gem called Parser, which is very popular, which is used by most of the syntax analysis tools in Ruby, including RubyConfBY, for example, or Mutant, which is used for mutant testing. So, and what's good about Parser, it's written in pure Ruby, so it doesn't deal with C extensions or whatever. It's version independent, so you can run Parser in the older version of Ruby to parse the newer Ruby code, which isn't possible with Reaper or abstract syntax tree module. And it's, as I said, been used by many libraries, by many applications using these libraries for a long time. And what's also a reason why I'm choosing this, because originally Parser was built by White Quark while she was working at Evil Martians. And another good thing about Parser being such a popular tool, it has a counterpart called Unparser. So this gem actually covers us in the last phase of our transpiling pipeline. It allows us to generate a source code from the AST produced by Parser. One thing we should note about this library and the approach it uses is that the final source code generated by Unparser could be different from what you used as an input, because Unparser doesn't care about the original layout, original syntax. It only cares about the structural representation of your code. Parser is not an ideal solution because, Ruby is tricky. Ruby has some very, very interesting syntax cases which are not supported by Parser. It doesn't understand it correctly. But I believe in real life, it's really hard to find these examples. So I think that Parser is good enough for what we want to do. So for building a transpiler, and we're going to use it. So transpiling with Parser looks like this. So we parse the source code. We have something I call rewriters. So every feature has its own rewriter responsible for transforming this AST to the compatible code regarding this feature. So we pass the AST through these rewriters, and then in the end we have some new AST, and we pass it to Unparser to get a source code. So what is a rewriter? That's again an example of method reference rewriter. We just replace a methref node with a send node, calling method, and passing method name as an argument. So that's all we need to do. So we transform this node of the AST to the node compatible with all the versions. That's a very simple example. If you take a look at the rewriter for pattern matching, it's almost 1,000 lines of code. Because, pattern matching is not that easy. It's just replacing, it's not just a syntax sugar, right? It's a new functionality. So let's take a look at the result of transpiling pattern matching, simple FizzBass program written with pattern matching into Ruby 2.5 compatible syntax using this approach by regenerating source code from the modified AST. The resulting source code doesn't look really readable, and that's okay because humans shouldn't care about the code, the transpiled code. We only care about the original implementation, and that's the idea of transpiling. You use some modern, concise, readable representation of the code, like pattern matching, and you don't care about the underlying code which is going to be executed by the Ruby VM or whatever. But we should take a closer look at this, and we can notice this thing. The source code had 7 lines in total, and the resulting code has almost twice more. What does it mean? So that means we have a problem. Imagine you have this transpiled code and you have an exception in it. And then your exception tracking software is showing you the line of the exception where it occurred. What are you going to do? You know where this exception actually came from? You don't have this transpiled code usually in your application. You don't know about it. When you refer to the code, you use the original version. But if the lines don't match, if the layout of the transpiled code is very different from what you had in the beginning, it's really hard to debug the problem. You don't know what's going on. Your favorite tools like Pry won't work because they use the original source as a location of the method when you're using them. So we need to fix this somehow. So we can't just use Unparser to generate a new source code because the new source code won't be of the same form as the original one. That's not a good developer experience. So let's take a look at what we can do else. How can we improve our transpiling process? Hopefully, Parser has a solution for us. It has rewriting support. So it has an API to rewrite code in place. So for example, so our transpile code will change to something like this. It's, doesn't matter what it's going on here. So we just generate some kind of buffer and transform it. Doesn't matter. Let's go to the rewriting example. So now instead of modifying the AST, we're no longer modifying the AST. We're just using it as a source of information about the source code. And we can use some helper functions to replace the original source code with the new source code. That acts like our naive approach with GSUP and regex, but it's much smarter because now we have a context. We know that we're doing the right thing, that we're replacing exactly what we want to replace. And that's how we can make the resulting code, transpile code, look more like an original one. So in the end, we have the following pipeline. We have an AST. We use this AST to apply in-place rewriting. Sometimes we also use Unparser to generate parts of this, replacements, because there could be some tricky syntax constructions we cannot just rewrite using strings. We better use AST and generate a valid Ruby code. And that's a new source code. If we take a look at the example we saw before, here is the transpile code using this rewriting mechanism. So we preserve the lines of code. We have a bit different form, right? So we have some semicolons here and there just to make sure that the lines number are equal. But in the end, that will allow us to seamlessly use our developer tools with this transpile code. So let's talk about another thing. So looking at this example, we see that the transpile code has much more, it seems that it has much more operations. What about performance? Is there any difference how slower the transpile code is, or maybe faster? So the funny thing here is that the transpile code for pattern matching, so the pattern matching is the most complex part of the transpiler as of now. So the pattern matching in the transpiled form, it's transpiled version with case when statements. In many situations, not in all of them, but in many situations, like in the example I have here, that's actually slightly changed code from the newer Hanami API gem. So it's not a synthetic example, it's real life. So in this case, comparing Ruby 2.7.1, the original execution to the transpiled code execution, transpiled code is almost 1.5 times faster. And that surprised me in the first moment, because I was thinking about, okay, if my transpiled code gonna be, twice slower, that's maybe okay. We still can use it, but it turned out it's faster. As it turned out, I added a bunch of optimizations while writing the transpiled version of the code, which were not present in the first version of pattern matching for Ruby 2.7. So I started to thinking about backporting or forward porting, I don't know how to call this, these optimizations back to Ruby, which is much trickier than writing them in Ruby itself, because you have to deal with Ruby VM stacks and C and all that stuff. But anyway, the first PR has been merged recently, and now the difference won't be as big as in the previous slide. I don't know exactly. I think it's going to be about the same. So for this particular case, for array patterns, I think the performance has been improved drastically. But for other cases, we still need a lot of things to do to make it better. Let's talk a little bit about how we can use the transpiler and what how a transpiler for interpreted language works. So we usually don't have a build phase when deploying or releasing Ruby applications. We just put source code somewhere and run Ruby something. That's it. We do not have build pipelines. So we can do the following things. First, for gems, I'm not going to talk about it today, but for gems, I still I recommend using some kind of a build phase and release gems with a pre-transpiled code included into the package. We have some tools for that. But for applications or scripts, we can transpile at runtime. So Ruby is really flexible. We can, monkey patch pretty much everything. So let's monkey patch kernel require and do all the transpiling in runtime. That's not something you're gonna do often, like patching kernel classes, especially those responsible for loading code in your application. But that's what we have in Ruby Next, and that's how it works. I just want to share some ideas behind it because it reveals how Ruby works. So yeah, we can just patch kernel require method, and all the require calls would be intercepted by our patch, and we can just load the source code, transpile it, and evaluate. So we need to know about two arrays, that RubyVM keeps to implement the require mechanism. First, it's a load path. It's a search path, actually, for features, for files, for Ruby files that you require. That's why we don't need to use absolute paths for gems, for example, because they add it to the load path. And the second one is loaded features. That's an index of all features or files that were required. So we don't need to require them twice because require only loads a file once. So that's how RubyNext require looks like. We check for loaded features, we resolve the feature path, we transpile the code, we evaluate it using ISEC, which is too deep to talk about now, and we add this to the loaded features to avoid loading the same code twice. And that's kind of works. That's not just kind of works, I'm using it. So that works. Also, we have a very interesting, just a funny thing, which also required a lot of work with some Ruby hackery, something that I showed at the very beginning. So this RubyNext switch, it works the following way. So first of all, the switch is just -r ubinext. So it's just requiring or loading ubinext file. So that's no magic here. That's how Ruby works. And this ubinext RB file is having a lot of interesting things inside. So first of all, it's trying to catch the exceptions happen during the execution of the code you're trying to run. So syntax errors or undefined method errors. We try to catch them and transpile the source code which were passed to the command and run again. And if it works, it works. If not, then we re-raise the original exception. That's how it works, but we use different techniques to do that. Finally, for kind of safer runtime patching, you can use Bootstrap, which also patch require, but it does it much better than I do because I just spend much less time on that. And Bootstrap has been used in production for years now. And you can take a look at some examples of gems applications and libraries in other languages, not MRI, using RubyNext. Actually, if you use an anyway config gem, for example, you're already using RubyNext, even if you don't know about it. You're using the modern Ruby syntax. So RubyNext source code is available on GitHub. And I advise you to take a look at this and give it a try. If you want to use modern Ruby features, there is no need to wait for next Christmas, this Christmas, next Christmas, whatever Christmas. You can use it today with RubyNext, and it's free and it's safe and it works. Thank you very much. My name is Vladimir, I'm from Evil Martians, and I was talking about transpiling if you got the idea. If not, please ask me questions, I will be glad to answer all of them.